Hello, everybody. So this is going to be basically bath bomb chemistry or bath bomb science. You could also say it's an acid-base reaction because it is basically an acid-base reaction. But yeah, so basically my objective for this was to make bath bombs, and I wanted to be fun with mine. So I was like, okay, let's make 6 of them. Okay, but what I wanted to do was get 2 recipes online or from this website, and then basically see if I can get those 2 recipes, and then see if I can improve on it and even make a better, bath bomb. In the end, make it better than you know both of them. So that was basically my goal for this video, which the recipes are going to be posted right now. Boom. All right. So yeah. So those two. The only difference is the amount, size, and servings. Basically, all the ingredients stay the same. I believe all I changed was the yeah, basically just the serving size. Um, but yeah, okay. So yeah, let's get into it. So the ingredients I used for a bath bomb, you're gonna need an acid and base. Um, so it's gonna be baking soda, citric acid, and then we're gonna get cornstarch and Epsom salt. That's gonna be for the dry mixture. Okay, it's gonna be 2 mixtures. That's gonna be the dry, and then the second is gonna be the wet, which is oil, a little water, food coloring, and fragrance. So the first two, yeah, basically baking soda and citric acid are what make the bath bombs fizz. The rest ingredients mainly help with structure, texture, and how fast it dissolves. So when mixing the dry ingredients, uh, you want to start by mixing all the dry ingredients together in a bowl. This includes the baking soda, citric acid, cornstarch, and Epsom salt. Mixing really, really well helps your bath bomb fizz evenly and gives it a smoother texture. Uh, Now let's get into mixing the wet ingredients. We're gonna just keep it simple. In another small cup, I mix the oil, a little bit of water, fragrance, and any coloring I want to use. I keep the wet ingredients separate because we don't want to activate the fizz early. Uh, when combining both the wet and dry, you gotta slowly add the wet ingredients into the dry ones while stirring nonstop. The key here is basically to go slow. If you pour too much water at once, it will start fizzing immediately, and we don't want that yet. The mixture is ready when it feels like slightly damp sand and holds its shape and squeeze, which is why sometimes you'll see me try to squeeze it to see if I get that texture. Um, and then yes, this is a very tedious process, by the way, as you can see in the video. I believe it took me. You guys are seeing this in probably maybe 20 times speed or 10, but it took me quite a while. And it wasn't until later I discovered like a way better, how like faster and everything, because you're supposed to count how many drops, but it literally just took the whole beaker. Like it took my whole solution. So yeah, you just have to be careful when adding it. So it's like a titration. Yeah. But I mean, I did get through it in the end. As you can see, I'm mixing it. You gotta, just make sure you get everything good. And you can even see it turn green here. So like knew I was doing good. If you get that type of color with your food coloring, you basically means you're almost there. So that's basically me mixing everything. I cut spaghetti break. Yeah, I had to eat, guys. Sorry about that. Uh, but yeah, basically, yeah, it's yeah, we're still going. Wow. Okay. All right. Well, let's get to packing the mold then. How that would basically work. So oh yeah, look. So basically, packing the mold is just overfilling it, packing it. Boom. I was so proud. Look right here. Look right here. Oh my God, you can tell. I I was so happy in that moment. I was like, yes, I did. And there was a second one. Those of two. So those are the first two. Yeah, they're about 2.4 inches of mold. Then you put them in the oven. I put them for 175 preheat, and then I just left them inside for 45 minutes, basically just to dry. And then once I left them in the oven to dry, I started working on my second one, which is the extra one. So there's literally only 2 differences between the first and second, and I believe it's literally just the amount of, I think, cornstarch changes and then some water in the oil. You'll see it right here. Hold on, let me check again. Okay, okay, so that's what it is. Whatever it is right there, it's right. So if I was wrong, that's right. Okay, so uh, now that we're basically in the back, we're just gonna see me literally making the same thing twice, just with extra cornstarch. It's literally just gonna be um yeah, I'm gonna do this 2 more times because it's gonna be the extra cornstarch one, which is red by the way, and then the normal one's green, and then I believe mine was blue. So yeah, so now we're gonna basically you know, go into like the more like advanced of it right now. So the basic science of like why it fizzes is, so when the bath bomb hits water, the baking soda and citric acid dissolve and start reacting with each other. That's, reaction releases carbon dioxide gas, and those gas bubbles are what make the bath bomb fizz and break apart. Okay, so now that I made the bath bomb and tested it, here's basically like the deeper chemistry of to like why it actually fizzes. Baking soda is sodium bicarbonate, and citric acid is a weak organic acid. When they're dry, nothing happens because they need water to dissolve them. Everything needs water. Okay, water, water, water. So as soon as water hits the bath bomb, the citric acid releases hydrogen ions. Those hydrogen ions react with bicarbonate ions from the baking soda, forming an unstable molecule called carbonic acid. Carbonic acid immediately breaks apart into water and carbon dioxide gas, which is why it fizzes. So, the carbon dioxide gas is what you see as bubbles. So, what the reaction looks like right here. Boom! NaHCO3 plus C6HAO7. This gives you product of CO2 plus H2O, which is sodium citrate. Okay, plus sodium citrate. And then cornstarch slows the reaction down, oil controls how fast water gets inside, and Epsom salt strengthens the structure so it doesn't crumble. Hot water makes the reaction go faster because everything dissolves more quickly. Cold water slows it down for a longer gentle fizz. So if you want to enjoy your bath bomb, I'd say take a nice cold bath or shower. But yeah, look at that. Ooh, perfect form, almost done. And then I think about this point, I'm ready to just throw it in the box. Yeah, so that's about it. So that's, I believe, what I'm about to do. Okay, but let's see here. What do you think happens? A, there is no fizz. B, nothing happens. Or C, everything goes well. Or D, it explodes. No, this can't be. There's no way. Play it back, please. Please. Well, surely the others can't go wrong based on just the first one, right? Because it just didn't stay together. Yeah, right, guys. All right. So this is the first one. That was the first time. Like 133. That was the second one. 22487. And then this was the starch one. And yeah. So I think this one lasted more longer. Maybe I think this one had the extra starch. Um, yeah. And so since there's extra starch, according to what I said before, more starch, it acts as like more of a barrier between the water and the acid. So yeah, checking the temp right there just in case. And now I needed to lock in because all my bombs didn't have a spherical shape. So yeah, this is my last attempt, guys, right here. So hopefully this goes well. I This is doing my own recipe now. So hey, maybe the recipe failed me. Okay, maybe they didn't do it right. So yeah, this next part, I kind of ran out of time to edit this video. I'm not gonna lie, it is literally like almost midnight. But here's just gonna be me. Yeah, and then I'm just gonna have some fun facts playing in the background. Yeah, hope you enjoy. You'll see if I actually end up making it right this time or not using my recipe, which I will post right there in your face. Hello recipe, yeah. So hopefully that one works. All right, see you guys.
Fun and interesting bath bomb facts. Bath bombs were inspired by Alka-Seltzer tablets. The fizz reaction is similar to the one used when baking cookies and cakes. Bath bombs release aromatherapy scents quickly due to their warm water convection. Cornstarch acts as a speed limiter to control fizz duration. Epsom salt changes the feel of the bath but not the fizz. Fizzing creates convection currents that swirl colors and patterns. Gas-forming reactions slightly cool the bath water. Water temperature changes the fizz speed dramatically. Some bath bombs float because trapped CO2 lowers their density. Cloudy bath water comes from a temporary emulsion of oils and water. Certain dyes can make bath bombs act as pH indicators. Citric acid used in bath bombs is often made using Aspergillus niger fungus.